Okay, for this problem it says what is the function right here approaching as x approaches infinity. Okay, it's a horizontal asymptote question. We don't have to get a common denominator or anything. All we got to do is look at the powers of each part of this. Here's a part right here. Okay, the degree on the top is to the 0 power because there is no x. The degree on the bottom is to the first power. So when the degree of the bottom is bigger than the degree on the top, then it goes to 0. So this bit right here goes to 0. So we got 0 for this part. Let's look at the next part. This part, the degree on the top is first power, and the degree on the bottom is also first degree. So when the degrees are the same, you look at the leading coefficients. So the leading coefficient here is 3, the leading coefficient here is 6. So on the first part, we got 0, and this plus, the second part is 3 6. And 3 6 is just 1/2, so we have 0 plus 1/2, or just 1/2. So the limit as x approaches infinity for this function right here is going to be 1/2. I can tell you that it's going to level off to a height of 1/2, that function right there. Here's another one, another horizontal asymptote question. What is y approaching as x approaches infinity? Well, first of all, a negative exponent flips it down, flips what's to the negative exponent, the x plus 2, gets flipped down to the bottom of the, down here in the denominator. Now compare each part. No x's on this, so this is just 4. There's an x on the bottom, so as the x's get bigger, this is going to go to 0. Look, think of putting a million in there, or look at the degrees. The degree of the top is 0, degree of the bottom is 1. If the degree of the bottom is bigger than the degree of the top, it goes to 0. Same way with this. This is going to go 0. Degree of the bottom is 1, degree of the top is 0. So you get 4 minus 0 plus 0. 4. Here's another one. Let's take a look at, back to this one. Same problem. What is the location of any vertical asymptote? Well, how do you find vertical asymptotes? Set the denominator equals 0. Each denominator. There's no x there, so we don't get anything. Here, x equals 0. Here, set the x plus 2 equals 0, and you get x equals -2. So there's two vertical asymptotes, one at 0 and one at -2. Just make sure that they don't make the numerator equal 0 if you substitute those values in for x. Well, there's not even an x up there to substitute in, so those are your two answers. The vertical asymptotes are at 0 and -2. Now, x-intercepts does take some work. So to find the x-intercepts for this equation or this function or this equation right here, first of all, flip it back down. Now, you have to get a common denominator. So the first thing here, you're going to have to multiply this top and bottom by x and x plus 2 on the first one, top and bottom. Okay, so I did the 4 over 1 and I put an x plus 2 top and bottom. This one's missing the x plus 2, so I put an x plus 2 with that top and bottom on that. Give yourself room. And then this one's missing the x, so I got to put an x with that top and bottom. Now that we got the common denominator, we can just write all this junk over here over the common denominator, x times x plus 2. So here's all that junk on the top. Now just distribute across. So 4x distributed across, that will give you 4x squared plus 8x. Take the minus 3. A lot of people forget to distribute the negative. Negative 3 times the x plus 2 will give you negative 3x minus 6. And then the plus 5x. So now we're just combining like terms here. So the 8x minus 3x is 5x plus 5 more x puts you to 10x. So we get this right here. Now where do we find x-intercepts? Well, we get the x-intercepts by setting the numerator equal to 0. This is the numerator right here, so we set that equal to 0. If you set that equal to 0 and solve it, it's a quadratic. You could actually solve it on the quadratic sheet. Let me put in the coefficients in the quadratic sheet of 4, 10, and -6. So let me go to the quadratic sheet. And 4, 10, and -6. And what x-intercepts do I get here? 0.5 and -3. So they are your x-intercepts of -3 and 0.5. Now you got to make sure that they don't make the denominator equal 0. If they did, they would not be x-intercepts. So let's check it here. First of all, you can tell if these would make the denominator equal 0 because if they did, it would be the same factor top and bottom, which would cancel out. So we have no common factors here, so they don't cancel out. Now we didn't factor it, we solved it. So if you put look right here, you can tell what makes the denominator equal 0. 0 and -2. So they're not going to, they're not the same values as we have here. So those are your x-intercepts. You could also factor this and set each factor equals 0, but it's probably easier just to use a quadratic sheet. Okay, here's another one. What is this approaching as x approaches infinity? It's looking for a horizontal asymptote. This is 4. The powers or the degrees are the same here, so you look at the leading coefficient, 3 and 2. So 4 minus 3 halves, and then here the degrees are the same too. So look at the leading coefficients, 5 and 1. So we get 4 minus 3 halves plus 5, which is 7.5. Another one, what is this approaching as x approaches infinity? Horizontal asymptotes. Look at the powers. Here's just 4. Power on the top is bigger than the power of the bottom. When that happens, there's no horizontal asymptote, and it's approaching infinity. So this is heading off to infinity. And this here, you flip that down the bottom, and they're the same power. So you look at the leading coefficients, 5 over 1. So we got 4 minus infinity plus 5. Well, I don't know about you, but minus infinity seems to take the works on this. So 4 minus infinity is still minus infinity. Minus infinity plus 5 is still minus infinity. So it's heading off to actually negative infinity, but good enough for us right here to say infinity on this one. So we'll pick it up with undefined points then on the next video.